If 1,200 centimeters square of material is available to make a box with a square base and an open top, find the largest possible value of the box. So this is an expanded view of a box. Note that it is mentioned in the title that this is a box without top. So it has only one button. We let the one side of the square be x and the side of the rectangle be y. The area of a rectangle can be calculated by multiplying one side by another side. So we can get the following formula. Because the question is asking for the maximum value, so we can also express the value using x and y. At this time, we have two formulas at the same time. We can express y in the area formula in terms of x, and then put into the volume formula, so that the volume formula only has x. We simplify this formula and we can get this. This is the volume function of this cuboid. And the question requires us to find the maximum value. Then we only need to know the highest point of this function. At this time, we can use the function after the derivation of this function to find its local maximum. So we need to get the derivative of this function first. So first, we can change the numerator to 1, and we can use power rule to change this into this. And 300 times x will simply be 300. So this is the graph of the function, and this is the graph of the derivative of the function. And of course, the highest point is the answer. The principle is very simple. If a line first increases and then decreases, then we must have a bulging place. And that point is a local maximum. So when the function after derivation is below 0, the original function must be getting smaller. When it is above 0, the original function must be increasing. If the derivation function returns from below 0 to positive, it means that the original function is at the moment when it has just finished declining. So at this time, the original function must be the smallest. If the differentiated function returns from above 0 to below 0, it means that the original function is at the moment when it has just finished rising. At this time, the original function must be the largest. So we need the x-intercept of this 2 point. The x-intercept is the point at which the graph crosses the x-axis. At this point, the y-coordinate is 0. So we can set the y be 0, and we can get 2x. According to what I just said, negative 20 is the coordinate of x at the lowest point, and positive 20 is the coordinate of x at the highest point. This paragraph means exactly the same as what I explained before. X refer to the side length of the square, which means that when the side length of the base of the cuboid is 20, the cuboid is the largest. We get the answer when we put the 20 into the volume formula from the beginning.